Welcome to ECB Tech. Today's topic is conjugate of a matrix. What is conjugate of a matrix? First, before discussing the conjugate of a matrix, first we have to discuss the conjugate of a complex number. See, conjugate of a complex number. What is this conjugate of a complex number? Suppose, for example, if a plus ib is a complex number, then the conjugate of a plus ib is a minus ib. Okay, it is denoted by a plus ib whole bar equals to a minus ib. So here what happened, if a plus ib is a complex number, then the conjugate of a plus ib is a minus ib. It is denoted by a plus ib whole bar. This means conjugate of a plus ib is a minus ib. But here we have to understand that means simple logic is replace I by minus I. This is the simple logic. Replace I by minus I, then you will get conjugate of a complex number. Suppose, for example, if a plus I0, that means simply it is a, is a real number, then the conjugate of a, that means a plus I0 is again a minus I0, that's simply a, that is a plus I0, conjugate of a plus I0 simply a bar is equals to again a minus I0, therefore simply a. That means here also we replace plus I by minus I, then we will get the same number. Therefore that means the conjugate of a real number 2 bar equals to 2. Conjugate of a real number is 2, and conjugate of a real number is always itself. Minus 2 bar equals to 2. See the another example. 2 plus 3i. What it will do? Replace I by minus I. 2 plus 3 into I, at the place of I we have to replace minus I. Then you will get 2 minus 3i. So this is the conjugate of this number. Similarly, from 3 minus 4i, conjugate of this number. So replace I by minus I, then minus into minus plus, therefore 3 plus 4i, therefore from b plus ic, conjugate of b plus I. So b plus, at the place of I we have to replace minus I, then we can write b minus ic. So these are the examples for conjugate of a real number and conjugate of a complex number. Now we want to discuss the conjugate of a matrix. Conjugate of a matrix or conjugate of a matrix. A matrix obtained from any given matrix a matrix obtained from any given matrix capital A on replacing its elements by the corresponding conjugate complex numbers is called conjugate of your matrix. It is denoted by A bar. Once again, see, a matrix obtained from any given matrix capital A on replacing its elements by the conjugate complex numbers, corresponding conjugate complex number. So the elements replaced by conjugate complex numbers, then it is called a conjugate matrix of capital A, and it is denoted by A bar. See an example. Suppose, for example, here I am taking a matrix A equals to 2 plus I, 0, minus I, here 3 plus 4I. This is the one matrix. It contains some complex numbers and also some real numbers. So I want the conjugate of A. It is denoted by A bar. So according to definition, replacing its elements by conjugate complex numbers. So conjugate complex numbers means already we discussed. So we have to replace 2 plus I is replaced by its conjugate complex number. 2 plus I conjugate is 2 minus I. 0 is the real number. The conjugate of a real number is itself 0. This is minus I. Minus I conjugate is replace. Conjugate means minus I conjugate is minus I into minus plus I. Here 3 plus 4I. The conjugate of 3 plus 4I is 3 minus 4I. That means simply replace I by minus I. This is the simple logic. Replace I by minus I, then you will get new matrix that is called conjugate of that matrix. It is denoted by A bar. See the one more example. B equals to 1 minus I, 2 plus I, 2 minus I, 3I, minus 4 plus I, here 4I minus 2. So now I want the conjugate matrix of B. It is denoted by B bar. What I told you is just replace I by minus I. Replace 1 minus, in the place of I we have to replace minus I. Minus it by plus I, 1 plus I. Here 2 minus I, 2 plus I, and minus 3I. Here minus 4 minus I, minus 4I minus 2. That means here we replace I by minus I. We got the new matrix. It is called the conjugate complex of B. It is denoted by B bar. Now write the properties. Now come to the next one. Properties of conjugate matrix. What are the properties of conjugate matrix? See the first one. A conjugate whole conjugate. A conjugate whole conjugate is equals to A. In the complex numbers also already you know Z bar whole bar equals to Z. Z bar whole bar equals to Z. That means A plus IB whole bar and whole bar, that equals to A plus IB. Come to the second property 2. A plus B whole bar equals to A bar plus B bar. Third property, complex Ka whole bar equals to K bar into A bar. About the property number 4, AB whole bar equals to A bar into B bar. These are the 4 properties of conjugate matrix. See the first property, A bar whole bar equals to A plus B whole bar equals to A bar plus B bar, Ka whole bar equals to K bar into A bar, AB whole bar equals to A bar into B bar. These are the properties of conjugate matrix. Now come to the transpose of conjugate of a square matrix. This is a very important topic. Transpose of the conjugate of a square matrix. This is a very important topic. Transpose of conjugate of square matrix. Already you know these 3 terms. Square matrix means already you know number of rows, number of columns are equal. Conjugate means just replace I by minus A. Transpose means interchange corresponding rows into corresponding columns or vice versa. So here what is the transpose of conjugate of square matrix? If A is a square matrix, and its conjugate is A bar. Already we discussed. A is a square matrix and its conjugate is denoted by A bar. Conjugate means replace every element by its conjugate complex number. That means replace I by minus I. Then it is denoted by A bar. Then the transpose of this conjugate matrix A bar is A conjugate whole transpose. A transpose. It is denoted by A power theta. It is denoted by A power theta. That means A power theta means A conjugate whole transpose. So once again see, if A is a square matrix and its conjugate is denoted by A bar, then the transpose of A bar. Transpose of A bar means first we have to find the A bar. After that, transpose A bar. A bar means replace rows by corresponding column or columns by corresponding rows. It is denoted by A conjugate whole transpose. Or it is denoted by A power theta means A conjugate whole transpose. Okay. Now here we have to note one thing. What is that? A power theta. A power theta means A conjugate. That means first we have to find the conjugate matrix. After that we have to transpose this matrix. And also otherwise, first we can find the transpose of a matrix. After that we can conjugate this transpose. So both are also same. Now we can see some of the examples we can easily understand. Okay, transpose of conjugate of a matrix. A square matrix means first we have to find the conjugate. After that, this conjugate we have to transpose. See the example. You can easily understand this example by this example. Suppose, for example, I will tell you one thing. A equals to 5 plus 2i, 5 plus 2i and 3i, 0 minus I, 4 plus 2i and minus 3 minus 9i. This is the one matrix. Now I want then find transpose of conjugate of a square matrix. Yeah. That means I already told you first we have to find conjugate. First we have to find conjugate. After we have to transpose this matrix. Therefore, first we have to find the solution. First we have to find the conjugate. Conjugate of A. Conjugate of A is denoted by A bar. How can we find A bar? If you want A bar, first we have to replace I by minus I in A. Yeah, so that's why that means A bar equals to, see the matrix A, 2 plus 5 plus 2i. At the place of I, replace minus I. Then you will get 5 minus 2i. Here 3i. At I, we have to replace minus I. Then you will get minus 3. This is 0. 0 is the real number. It's not a complex number. Therefore, simply you can get the same number. Here minus I. Here minus I. If you replace I by minus I, minus into minus plus I. Here 4 plus 2i. If you replace I, you will get 4 minus 2i. Here minus 3. Here minus 9i. If you replace I by minus I, you will get minus into minus plus I. That means plus 9i. This is A bar, conjugate of A. Now we require transpose. In the first step, we find conjugate of a square matrix. Now we have to transpose. Transpose means we have to interchange the rows into columns. So here A conjugate already you have. We have to transpose. Transpose means we have to replace the rows into columns. Interchange rows into columns. So here what is the first row? 5 minus 2i minus 3i and 0. That means here the first row converted into first column. Similarly, second row converted into second column. I 4 minus 2i minus 3 plus 9i. So this is the A conjugate transpose or transpose of conjugate of A. It is simply denoted by A power. This is the example. Okay. Now come to the next one. So also, okay, we can discuss one more thing here. What is that? We can discuss one more thing. What is that? Here first we calculated A bar. Otherwise, you can calculate first A transpose. This is the one of the another method. First, we can transpose. You can find the transpose of A. So, what is A? 2 plus 5 plus 2i 3i 0. This is the first row. Convert into first column. First column is 5 plus 2i and 3i and 0. And the second row. What is the second row? Minus I 4 plus 2i and minus 3 minus 9i. This is transpose of A. Now we can calculate conjugate of this transpose. So conjugate means this is the A transpose. Whole conjugate. Whole conjugate means replace I by minus I. So 5 plus 2i. If you replace I by minus I, you will get 5 minus 2i. This is minus I. If you replace this is minus I. If you replace I by minus I, minus into minus plus I. Here 3i. If you replace I by minus I, then you will get minus 3i. Here 4 plus 2i. If you this conjugate is 4 minus 2i. This is 0. This is 0. 0 is the real number. Its conjugate is also itself. So this is 3. To replace I by minus I, you will get minus into minus plus 9i. Again, we got the same matrix. Therefore, it is denoted by A power theta equals to A transpose whole conjugate. So this is, here you can observe A power theta equals to A conjugate whole transpose and A power theta equals to A transpose whole conjugate. Both are same. Okay.